All right, dealing with a little lesson this time, dealing with segments. Fairly simple concept. Segments are not really that big of a deal when it comes to things. So we're going to take a look at the interaction segments can have, not a big deal. We're going to take a look at the idea of midpoints and the idea of betweenness and what that means. And then we're just going to take a look at the more important piece, which is what you might need to do in order to solve a segment. So first of all, interactions. Segments obviously don't have to be the same length. These two, particularly the ones that I've drawn here, aren't even going in the same direction. But they do not intersect. The segments don't. Now if I extended them into rays or lines, they might intersect, which would keep them from being parallel, which is a concept we'll take a look at another place and time. But the whole idea here is that segments interact. They intersect if they actually touch somewhere, even if they only touch at a single point. So if I come down here real quick, make that an angle, that's intersecting segments. The intersection is here at the endpoints, which obviously makes an angle, but that's pretty much all there is between the intersections. Now, I want to talk about two things here, midpoints, and I want to talk about the concept of a bisector. Bisector happens in more than just segments. Midpoints is a segment-only concept. The idea of a bisector, however, is not a segment-only concept, but let's take a look here real quick at what those two things are. Let's first of all say we have a segment. So we're going to say this is segment AB. The exact middle on segment AB, meaning that the distance from here and the distance here, the distance from the two ends, that spot is called a midpoint. Obviously on this segment you have an endpoint, two endpoints, and then you have one midpoint. That means this piece on this side is equal to the piece on that side. That convention there is saying that this segment is equal to that side. That's a way to mark it. The little slash marks on there show that the segments are the same. A midpoint is also something else. A midpoint is a segment bisector. Now the word bisect in geometry, the word bi means two. Sect means cut, so it means to cut it in two. Well, you can cut it in two anywhere, particularly if you dissect in science, you don't have to cut it right down the middle or anything of that nature. In mathematics, bisect does mean to cut it exactly down the middle. So in this case, the midpoint is a bisector. It is a point that cuts the segment into two equal pieces. However, a midpoint is not the only type of bisector there is. I could have a segment where a line comes through hitting at the midpoint. I don't think that drawing is probably very good. But this thing would then be called is also a segment bisector. So we might say something like ray CM bisects segment XY, if we make this XY, because it goes through the midpoint. If it's a bisector, it means it automatically cuts it into two equal pieces. Let's actually turn this thing into a ray as it heads through there. So it could be a point, it could be a ray, it could be a line, it could be another segment, it could be a plane even that slices through here and cuts it in half. Just because two segments bisect doesn't mean that they're both bisected. For example, in this drawing that I just gave here, maybe this segment is bisected, but the other one clearly is not, as the piece at the top. It just simply means that you now know that you're going through the midpoint. All right, last piece of the puzzle for this slide is the idea of betweenness. Between simply means that if I have 2 points, a point is between them if it is on the segment between them. So this point is not between points R and S. This point is between points R and S, and that is not a midpoint. Maybe it is a midpoint, maybe it's not. The way I've drawn this one here indicates that it isn't. Now, one thing students need to get used to in geometry is the idea of whether or not something's drawn to scale. If I gave you information that indicated this was a midpoint, even though it doesn't look like it in the picture, you follow the information that you're given. Nothing is what it is unless you have a way to prove or verify that it is. So if you want to say this is the midpoint because it's in between, you have to be able to show the segment on this side is equal to the segment on that side. All right, so then what about solving? Well, this is actually a pretty simple concept. Some of the work that you'll be doing here. So if I have a point in between, so let's say we go back to segments A and B, this is 5, the whole thing's 21, and and this is M. I can find all kinds of things here. If I want to know the length of segment AM, I can obviously do some pretty simple math there. By the way, let me introduce something else here in naming. We went over naming before, but there's one more thing about segments that you need to know. If you see AM like that, see there's no notation, there's no segment notation here, there's no line, there's no ray. What this means is the distance from A to M. So if there's no notation, it's talking about the distance, talking about a number. Well, in this case, that's easy. It's going to be 16. So I don't know if it's centimeters, let's call these centimeters, just for the sake of centimeters, this would be 16 centimeters. 21 minus the 5 piece on this side means that AM is equal to 16. Well, that's not the only problem you can come up with. You might be able to come up with something like this. If I say this is 3x plus 4, then that tells me I have to know 3x plus 4 plus 5 is supposed to be equal to 21. Smaller segment plus smaller segment equals the larger segment. So this is 3x plus 9 is equal to 21. So 3x is equal to 12. So x is 4. Be careful in these situations. Is x what they was being asked for in the question? Or are they asking you for how long it is? That depends. So is 4 the answer? Maybe it is and maybe it's not. It depends on what the context of the question is. The next piece here might be things like this, where I say this is 3x plus 4 and this is 2x minus 5. And I tell you that these two segments are equal, meaning that this is a midpoint. So let's say this is x, y, and let's call this n. N is the midpoint. If you know it's the midpoint, then you know you have equal pieces here. So you know you could set up something like this. 3x plus 4 is supposed to be the same as 2x minus 5. So when you do a little subtracting, 2x from both sides leaves x. Subtract 4 from both sides, you get negative 9. So x is negative 9. Would be the number that you plug in there to be able to solve this thing. Of course, this turns out to be a bogus answer because if you plug negative 9 in there, that's negative 27 plus 4, which is negative 23, and a segment can't be a negative length. Lengths are not allowed to be negative. But my point here is, more importantly than the silliness I just got going here, is there's two different ways generally to set up solving things with segments. One is small plus small, and it might be plus small, 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 small is equal to large. Or it might be that you have two pieces that are equal to each other and then solve for the x. And then again, make sure you're actually answering the question that is asked. A lot of students just assume when I got to x, I must be done. This is the answer. Maybe it is and maybe it isn't. Make sure you're answering the question that's asked. All right? So that's how you deal with segments. Until next time, see ya.